Hello, and welcome to our demonstration of basic static analysis. So, basically, now that we have our malware.exe file already installed inside our desktop, we're going to start by checking out to see whether that malware is packed or not. And to do that, we're going to use PID. So basically, very simple. What we're going to do is that we're going to load the malware.exe file into the tool itself. So we're just going to go to desktop, going to go to malware, open it, conduct a normal scan. So as you can see, we did a normal scan, shown us now, and there was no packer found. Why is this so? Because the EP section is showing .txt, which indicates an unpacked malware. So next what we can do is that we will go to the PE disassembler, which can be found here. So basically what all of this code does, right, is that it shows the entire raw code, but this time it's in assembly language format. So what this does is that it actually allows the user to see what the PE actually does inside the machine itself. So next step, we're going to find out if the PE has any known crypto algorithms, functions, and libraries instead of the specified ones. So what we're just going to do is that we're just going to so what we're going to do is just going to close it, and we're going to open the crypto analyzer plugin from within the PID itself. So we're going to just click here, go to plugin, we're going to look for crypto analyzer, and as you can see here, no known crypto signatures are found. So we basically found out that there are no crypto signatures found inside the malware itself. Next part of our analysis, we're going to conduct a hardcore scan to see if anything will show up. We're just curious, so we're just going to conduct a hardcore scan. And as you can see here, it actually throws something here. So MPEG layer 2 or 3 music file. So what we think this means is that it's suspected to be some sort of music file format. Next part of our analysis, we're going to go to PE information, which basically shows all the administration information of the malware itself. So we're just going to go to PE view. Basically, the tool is called PE view for information. Yeah, accept it. Click on malware, should be inside. Okay. Now, the first section will be image underscore DOS underscore header. Okay. Now, first of all, when we inspect this, as seen in the highlighted one, it is a signature of 5A4D, which stands for MZ. Now, interestingly, this MZ is actually the initials of Bob Zbigniew, which is actually one of the developers of MS-DOS. So this information is actually crucial as it tells us what information is actually contained inside the header itself. But to get a better understanding of malware, right, it's important for us to understand like the little bits of information that can be derived from. So, and one of the little bits of information that I mentioned just now would be the date of compilation. So where can you find this? You can find this under image score file header. So we can just go up here, and you can see here image file header. Now you can see that the Trojan, right, was created on the 13th of October on the Friday 8:39 in 39 seconds in the year 2006, and this measures the date inside the malware database itself. So next, what we're going to do is that we're going to navigate to the r.r data section, which is here, r data, and we're going to go to import directory table, which contains the DLLs that we saw inside PID. So we're just going to go here, import directory table. Now, all these files here, these are all the imported DLLs with function calls under the .r data section. Import hint names and DLL names also. But PView does not really show in quick detail into what the DLLs actually do. So what we have to do is that we have to explore the different DLLs. We will use another tool known as dependency walker, which will be covered in a short while. Now, just to use Windows MD5 tool, I'm just going to close this. We're just going to check the hash value of the malware that we use, make sure it's the correct one. So what we're going to do is we're just going to open MD5. As you can see here, the tool is here. We're going to browse for our malware, open it, and as you can see here, the hash value has already been generated. So we do know that the MD5 value is correct. So that being said, now we are going to move on to dependency walker. As I said previously, we using PE view, we do not really know what's going on inside the DLL itself. Yeah, we do not really know. So to know in greater detail, we're gonna use dependency walker instead. So just let us navigate to dependency walker. Let me just go back to it. Okay. So what do you use dependency walker for? Basically, we want to view the DLL files as well as any important functions that the malware has inside. So in order to do this, we have to load the malware into dependency walker. So basically the same thing as I did just now. We're just going to open our .exe file is inside the desktop itself. Just going to open it and let it load. As you can see here, it's all here. I'm just going to put it to full screen. Okay. So first of all, right, you can see our first DLL, imported our DLLs that are having here is basically kernel32.dll, add vapi32.dll, and also user32.dll. These are basically the three main DLLs that are inside the malware itself. So basically, now we're going to look at the imported functions. First imported function that we're going to look through is kernel32.dll. And we can see that the functions that have been created, the key ones that we want: create event, create process, get command line, get file time, get module file name, and so on. These are the important API functions that we want to derive to figure out what the DLLs actually contain, as mentioned previously. Now we're going to do the next API function, add vapi32.dll. So what you can see, right, there are mainly three important API functions inside this DLL, mainly reg close key, reg open key A, and reg query value exa. Basically, the function of reg close key, right, is that it closes a handle to the specified registry key itself. Next will be reg open key exa. So basically, what it does is that it's just the opposite to reg close key. Just that this time it opens the specified registry key. And last one is a reg query value exa. Basically, what it does is that it just retrieves the type and data for the specified value name associated with an open registry key. That is why there's this function here where you have to open the registry key first before reg query value exa gets to retrieve the type and data. Basically, this is how it works. And lastly, will be user32.dll. So as we look through, right, there's so many important functions, right, that are important for us. For example, there's like destroy window, close window, create window, translate message, dispatch message. There are really so many important functions that we can use to identify what kind of DLLs are really inside the malware and what is the true purpose of it being imported inside in the first place. Now we are done with dependency walker already. Lastly, we're going to go to bin tags. Now, just a quick overview of what bin tags is. Just in case most of you don't know, bin tags is basically, right, it's just a small but at the same time it's a powerful text extractor. And as I said before, we cannot just use dependency walker alone, because using dependency walker alone cannot determine all the attributes of our malware. So what we must do is that we must use other tools, which is bin tags, which is a powerful text extractor. So what we're going to do is that we're going to open bin tags now. Okay, cool. Okay, so first of all, right, is run against the unpacked malware to try and decrypt some of the data to form more readable strings that are easier for us to understand, and hence it can help us to know more about the malware itself, which obviously is what malware analysis is all about. So first we're going to do is that we're going to scan the file. As per usual, open the malware.exe file in the desktop itself. Go down, scan. there are pretty interesting strings here. For example, note that kernel32.dll is here, which was found inside dependency walker, get command line A, found inside dependency walker. Basically, right, you can see that all of these were found inside dependency walker, which matches. And these are the key DLLs and important functions that we need to identify what kind of malware and its information that we are actually dealing with. So yeah, this is the end of basic circuit analysis. Basically, now we have a better idea of the function inside the malware itself, the imported API functions, the imported DLLs, the purpose of the DLLs being inside the malware itself, the hash value, checksum value, etc.